In this video, we will discuss everything about DNS, an essential component of the internet, including how it works and its design. Hi there, welcome to Tech and Career Bytes. I'm a software professional with over 2 decades of experience, including 7 years in leadership roles at a global product based organization. Imagine you want to visit a website, let's say example.com. Without a DNS, you would need to remember the website's numerical IP address, which might look like 192.0.2.1. Hard to remember such strings of numbers, right? DNS steps in to bridge this gap. The DNS acts as the Internet's directory, converting human readable domain names into numerical IP addresses. Think of it like a digital address book, making internet navigation easier. Let's understand how it works at a high level. We can then dive deeper into its components and design. When you enter example.com into your web browser, the browser first checks its cache for the corresponding IP address. If not found, it then checks the operating system's cache. The operating system facilitates communication between the browser and the DNS resolver. If the IP address is still not found, the browser sends a request to a DNS resolver, which acts as a virtual librarian. The DNS resolver searches its cache for the mapping of example.com to an IP address. If the information is not found in the resolver's cache, it queries the ISP and after that DNS infrastructure for the IP address. You can see the cache usage at various levels in the diagram. Once the IP address is located, it is returned to the browser via the operating system, allowing it to connect to the correct web server and retrieve the desired web page. A DNS resolver could be from your ISP or from DNS providers like Cloudflare's 1.1.1.1 or Google's 8.8.8.8. Let's now understand the various components of DNS. In the domain name system, several key components work together to resolve domain names to IP addresses. Let's discuss each one of them. Name servers are specialized servers responsible for storing and providing DNS information. They maintain databases called zone files, which contain mappings of domain names to IP addresses and other DNS information. Name servers respond to DNS queries from clients by providing the requested information or referring the client to another name server if necessary. These name servers are structured hierarchically. We will discuss the details later in this video. Resource records are the fundamental data elements stored in DNS zone files. Each domain has its own zone file, typically stored on the name servers responsible for that domain. Each resource record represents a piece of information associated with the domain name. As seen earlier, DNS uses caching at different layers to reduce request latency for the user. Caching plays an important role in reducing the burden on DNS infrastructure because it has to cater to the queries of the entire internet. DNS name servers are structured hierarchically. This allows for scalability and efficient query resolution. There are primarily four types of DNS name servers. Let's discuss each one of them. DNS resolvers initiate the querying sequence and forward requests to other DNS name servers. Typically located within the user's network, these servers can also serve users' DNS queries through caching techniques. These servers are also known as local or default servers. Root level name servers handle requests from local servers and maintain name servers based on top level domain names like .com, .edu, .us, etc. For example, if a user requests the IP address of example.com, root level name servers will provide a list of TLD servers holding the IP addresses of the .com domain. There are 13 logical root name servers named letter A through M with many instances spread throughout the globe. These servers are managed by 12 different organizations known as the root server operators. Here is the list of those 12 organizations. These organizations are responsible for operating and maintaining the infrastructure of the root name servers. Top level domain name servers store the IP addresses of authoritative name servers. When required, they return a list of IP addresses belonging to the authoritative servers of the organization. Authoritative name servers belong to the organization and provide the IP addresses of web or application servers. They serve as the final authority for DNS resolution within the organization's domain. How are DNS names processed? For example, will example.com be processed from right to left or left to right? Can you guess? Here is the answer. The DNS names are processed from right to left. In the case of example.com, the DNS resolvers resolve the .com part first, then example, and so on. Now, let's explore how the DNS query resolution happens. In DNS query resolution, there are two main methods, iterative and recursive. Let's discuss each. In iterative resolution, the DNS resolver sends a query to root level name server and awaits either the requested information or a referral to another top level domain name server that may have the information. If the queried TLD name server lacks the requested information, it returns a referral to a different name server. The resolver then sends a new query to this referred name server. This process repeats until the resolver either receives the requested information or reaches the authoritative DNS server. In recursive resolution, the DNS resolver sends a query to a root name server and expects a comprehensive response containing the requested information. If the queried root name server lacks the information, it recursively queries other DNS servers, such as TLD and authoritative name servers, on behalf of the resolver until it obtains the requested information. The DNS resolver's configuration determines whether it performs recursive or iterative resolution. We saw earlier that the DNS query results are cached at various levels. Let's go a bit deeper. Caching occurs at various levels, including browser caches, OS caches, DNS resolver caches, as well as caching at the ISP level and across various tiers of DNS name servers. Web browsers often cache DNS records locally to reduce DNS lookup times for frequently visited websites. When a user visits a website, the browser may store DNS information in its cache to expedite future visits to the same site. Operating systems can also cache DNS records to improve system performance. OS level DNS caching stores DNS query results locally, reducing the need for repeated DNS lookups for frequently accessed domains across different applications and services running on the system. Caches maintained by DNS resolvers, such as those provided by ISPs or DNS servers, also store recently resolved DNS queries. Domain name server caches are maintained by name servers at various levels to store recently accessed resource records for the domains they are authoritative for. Root name servers, top level domain name servers, and authoritative name servers all utilize caching to improve DNS resolution efficiency. In essence, DNS serves as the Internet's address translation service, converting user friendly domain names to machine readable IP addresses. Without DNS, navigating the Internet would be like finding your way in a foreign city without a map or street signs. This would have significantly complicated online communication and accessibility. Thanks to DNS, we don't have to face that difficulty. If you found this video helpful, give us a thumbs up and subscribe to our channel for more interesting tech topics. Also, do check out our other videos on software performance optimization case studies, system design, coding, big data, and career growth. My name is Rupa, and I thank you so much for watching this video. See you next time.